Hello everyone, this is Kedesh here. In this video, I'm going to go through the AQA Physics Paper 1 Higher Tier, question number 3, which is on electricity. Figure 4 shows an electrical circuit used to heat the windscreen of a car. Each resistor in the circuit represents a heating element. So as you can see, this is powered by 12 volts and these are the resistors and which are arranged parallelly. So this is a parallel circuit. Question 3.1. The 12-volt battery supplies direct potential difference. Now remember, potential difference means voltage. So direct potential difference. What is meant by direct potential difference? Now is the same as referencing it as direct current. So when the potential difference is in one direction, or the potential difference polarity doesn't change, or the direction of the polarity doesn't change. The answer, the polarity or direction of the potential difference doesn't change. Use the physics equation sheet to answer questions 3.2 and 3.3. Which equation links charge flow, Q, energy E, and potential difference V? Tick one box. That would be energy equals the charge multiplied by the potential difference. Next question. Calculate the charge flow through the 12-volt battery when the battery transfers 5010 joules of energy. So remember, the equation is energy or E equals QV. So 5010 equals the charge multiplied by 12. Rearranging the equation, Q equals 5000 divided by 12. That gives me 417.5. 417.5 coulombs. Question 3.4. Ice forms on the windscreen at a temperature of 0 degrees Celsius. The electrical circuit transfers 5010 joules of energy to the ice. The mass of 0.015 kilograms of ice melts. Calculate the specific latent heat of fusion. Use the equation sheet. The equation that links specific latent heat and energy and the mass is E equals ml. So energy is 5010 equals the mass is 0.015 multiplied by the specific latent heat. Rearranging the equation, L equals 5010 divided by 0.015. That gives me 334,000 joules per kilogram. 334,000 joules. Remember, when we are calculating specific latent heat of fusion, the values are always higher compared to the specific heat capacity. Next question. The electrical circuit was left switched on while the ice changed from a solid to a liquid. So there's a change of state here, and then increased in temperature to 5 degrees. So the temperature is increasing from 0 to 5 degrees. Explain, which means you need to give reasons as well, the changes in the arrangement and movement of the particles as the ice melted and the temperature increased. So for 6 marks, you need to describe what happens to the arrangement in a solid and in a liquid. That would carry like 2 marks. And then describe the movement of the particles in a solid and in a liquid. Again, that's like another 2 marks. And then describe what happens when the temperature is increased from 0 degrees to 5 degrees, giving reasons. So if we break it down bit by bit, starting off with the arrangement of the particles. Right. Particles in a solid are in a regular arrangement, while in a liquid are in a random arrangement. So that is to do with just the arrangement. The next part is to do with the movement. Particles in a solid are vibrating. So if I label that as arrangement, and this would be movement. Particles in a solid are vibrating about fixed positions, while in a liquid are moving freely. As the ice changes to water, the temperature remains constant because there's a change of state. Because the potential energy of the particle is increasing. Now, what does that mean? That means the bonds between the water molecules are actually breaking up. Hence, the potential energy of the particle is increasing. As the water warms, the particles move faster. So the kinetic energy of the particle increases. The total internal energy, or the internal energy, is the total kinetic and potential energy of all the particles. That brings us to the end of the question, and I will see you in the next video.